Hello everyone, welcome to memoneet. So I am Aprajita, your chemistry SME. I hope your Brahmastra test series is going on well, students. So today we are going to discuss the solutions of BPT 10 for the chemistry portion. Okay, so we are going to start with the question number 51. So here you can see the question is for Arrhenius equation. The plot of log k against 1 by t is a straight line. The slope of the line is equal to. So here we had two chapters, that is chemical kinetics and the equilibrium. So this question is from chemical kinetics chapter, which is important, which talks about the rate of reactions. Okay, so here we have Arrhenius equation. All right, so they are saying the plot of log k and 1 by t is equal to. So here we have to tell the slope. This Arrhenius equation. So according to it, log k is equal to log a minus EA upon 2.303 RT. Now if I compare it with the straight line equation, you can see that the slope is negative in this case. So it is C minus mx. Okay. So the slope is negative here. If I compare it, so C is log A, means log A will be your intercept. Okay, so this will be the intercept. And if I talk about 1 by t, so 1 by t is this, like 1 by t. So means 1 by t is x. So the value of m will come out to be EA upon 2.303 R. Alright. So that is going to be your slope. Okay. So in this case, if I compare it, so slope is negative, no? So that's why we are saying it's minus EA upon 2.303 R. So the answer is going to be option number 3, since the slope is negative in this case. Now students, question number 52 says the first order reaction is 75% complete in 100 minutes. How long it will take for 87.5% completion? So for solving these type of questions, you must know the rate equation. Okay, the rate law and the equations for the first order, for zero order and for second order reaction as well. So if I talk about the question number 52, for first order reaction, the time for completion, it will be given by 2.303 upon k log to the base 10 R naught upon R. Now this R naught is the initial concentration. Okay, R naught means when the reaction had started, what was the concentration that at that time, and R is the concentration at time t. Okay, so that's what we will be taking. Now they are saying ki 75% reaction is completed in 100 minutes. Okay, so R naught means, if I talk about this thing, initial concentration, if it was 100, now 75% is completed, means at this time now 25% is left. So R is 25. So from here we can find the value of K. Alright, because time is given 100 minutes, so from here I can find the value of K, which is 2.303 upon T log of R naught upon R. Okay, so from here it will be log 4. You can keep it like this. Alright, 2.303 upon 100 log 4. Then we can directly put this K value in the next step. Now we have to calculate for 87.5% completion. So again the initial concentration will be 87.5. Now R will be 100 minus 87.5. So it's 12.5. So now 2.303 upon K log 100 upon 12.5, because I have to calculate the time. Ki kitne time par the concentration has or you can say the reaction is 87.5% complete. So from here we will substitute the value of K from the first equation. Okay. So when you will substitute the value of K, that is 2.303 upon 100 log 4, and here it will be log 12.5. So we will cancel it. It will be log 8. Okay. So 2.303 and 2.303 will cancel out. 100 will go in the numerator into log 8 upon log 4. Okay, So इसको you can write it as log 8 minus log 4 and you can solve it. So it will be coming out to be 1.5. So the time will be 150 minutes. Means in 150 minutes the reaction will be 87.5% complete. Okay. So that is the thing. Now question number 53, again it is talking about the rate of reaction. So here a reaction is given between nitric oxide and chlorine. So this reaction was studied at 10 degrees Celsius and the following data was obtained. So the concentrations are given, okay, NO and Cl concentrations, initial concentrations are given and the rate of the reaction is also given R naught. So we have to find out the order of the reaction. So you know students, ki order of the reaction is calculated from the rate law. So it says that rate of the reaction will be here K into, like if I am having two reactants, A to the power X, B to the power Y. So the rate of the reaction will be the sum of these stoichiometric coefficients in the rate equation. Okay, means X plus Y. So from here we can calculate the value of X plus Y. You can take any two values from here. Okay, so like if I take this 0.35, so rate is there. Now K into what is the concentration of the first reactant? 0.1 raised to the power X into 0.2 raised to the power Y. Similarly, I can take 1.40. You can take the first one as well, no issues. 0.2 ki power X and 0.2 ki power Y. So from here, we are taking this, so we will divide it. This will cancel out, K will cancel out. From here, you can calculate the value of X. So the value of X will come out to be 2. Okay, so it is coming out to be 2. Now in the same way you can calculate the value of Y. If I have calculated the value of X, so from here you can put the value of X and find the value of Y. So Y is coming out to be 1. So rate of reaction is sum of X plus Y. So it will be 2 plus 1, which will be equal to 3. Okay, so any two values you can take and you can find out the answer. Next question, students, 54. It says that rate of reaction triples, okay, means it becomes 3 times when its temperature changes from 300 to 310 Kelvin. Activation energy of the reaction will be, so what will be the activation energy, that you have to find out. Okay, so for that we need to know the your formula for activation energy, right? So let us see that. So students, for activation energy I can write that the formula will be log of K2 upon K1, okay, is equal to EA. EA is the activation energy, 2.303 R, and it will be different temperature, so 1 upon T1 minus 1 upon T2. Okay, so these are the rate constants at T1 and T2. Now it is given in the question that the rate of the reaction becomes triple, means K2 upon K1 ko hai 3. Okay, because the rate is becoming 3 times. All right, so that we can write, and from here we will put the values. Temperature 1, T1 is given 300 Kelvin, T2 is given 310 Kelvin, and the value of R is already given, 2 calorie per Kelvin per mole. So you can put the value of R as 2. Okay, and then substitute the value. Log 3 आएगा ना यहाँ पर, if I solve it, so it will be log 3 EA upon 2.303 into 2. So here you can write 1 upon 300 minus 1 upon 310. So log 3 ki value is already given, you don't have to solve it here. So similarly, like now you will do the calculation and find the value of EA. That is the activation energy. So it is coming out to be 20.561 kilocalorie per mole. So the answer is option 1. Okay, simple. If you know the formula na for these for this chapter, means if you know the formula of rate constants, the rate equations, activation energy, you can simply solve the questions. Okay, so that was another question. Now let's move on to question number 55. So here a reaction is given. Okay, So in the above reaction, if water is taken in a large excess amount as compared to ethyl acetate, then the order of the reaction is. Okay. So here we have ethyl acetate and water as the reactants. They are giving you ethanoic acid and ethanol. Alright. So they are saying ki if I am taking H2O in excess, okay, so then what will be the order of the reaction? Alright. So if we are taking H2O in excess, so the concentration of H2O can be taken as constant. Okay. So in the rate equation, here I will be having K into, we will be taking the concentration of only the ethyl acetate. Okay. And where this K value is K dash into H2, means the H2O concentration will also be constant now because it is in excess. So it means that the rate of the reaction is only depending on the concentration of your ethyl acetate. And here you know the coefficient will be 1. So it will be the like the value of X is equal to 1. Okay. Now the reaction is not first order, but it is behaving as first order. Alright. So in such reactions which are not actually the first order reactions, but they behave as first order, are known as pseudo first order reactions. So the answer is going to be option 3, because here the concentration of H2O, we are taking it to be constant because it is in excess. Okay students, question number 56. Assertion says the rate of the reaction is always negative. Reason: the minus sign used in expressing the rate shows the concentration of reactant is decreasing. Okay, so you know that the rate of the reaction is never negative. Okay, we are talking about at what rate the reaction is proceeding. So the rate of the reaction can never be negative. It's a positive value. Reason says the minus sign is used, that we are using in expressing the rate, shows concentration of reactant is decreasing. Yes, if we are talking about rate of the reaction, so we are talking about the minus value, means the rate at which the concentration of reactant is decreasing, means there is a decrease in concentration. So whenever there is a decrease in concentration, we use the minus sign. So reason is correct. Alright, means assertion is incorrect and reason is correct. The answer is option number 4. Okay, a very easy simple question. Next, question number 57. Okay, we have to match the column. Catalyst alters the rate of reaction. Okay, yes, so catalysts are the ones that change the rate of reaction. How they change of the reaction? They will not participate in the reaction, but they will lower the activation energy. Okay, if the activation energy of the reactants of the reaction is lowered, means the collision frequency will increase and the rate of the reaction will increase. Okay, so for A it's R. Next, molecularity. Okay, now molecularity of the reaction, it is actually the number of reacting species that are taking part in the reaction, okay, means which collide with each other to bring about the chemical reaction is called molecularity. So molecularity cannot be a fraction of or 0, okay, because we are talking about the number of reacting species. It can be 2, 3, 4, 1, okay, so it cannot be 0, because if there is no reacting species, the reaction will not happen, okay, and it cannot be in fraction as well because it's a whole number value. So it means molecularity cannot be fraction or 0. For B it's a P. Okay, second half life of first reaction, first order reaction. So students, you know that the half life is independent of the initial concentration of the reaction, okay, reactant. So first and second half life will be same. Okay, it is same as the first. So for C it's S. And energetically favorable reactions are sometimes slow because a proper orientation is not there. Okay, because there must be activation energy and proper orientation also. They will determine for the like effective collision. Okay, so energetically favorable reactions are sometimes slow because there is improper orientation between the molecules, so the collision will not be that much effective. Okay, so for D it's Q. So if we look at the answer, okay, here it is AR, B, P, C, S and D, Q. Answer is option number 3. Okay, yes, it's 3. Alright students, next is 58th question. 75% of a first order reaction was completed in 32 minutes when was 50% of the reaction completed. So same type of question we have just discussed, right? So here you will be applying the rate law equation and solving this particular question. So students, how you can do this question here, you can for first order reaction, again the one that we have just used, 2.303 upon t log of r naught upon r means, or you can say a upon a minus x means how much concentration was initial and how much is left. Okay, so for 75%, firstly you will write, so 75% of the reaction is completed in 32 minutes, so 32 I will write here, and it will be log of 100 upon 100 minus 75, you can write 25. Okay, same goes with here, it is 2.303. Now for 50% I have to find out, so I will write t here, log of 100 upon 50. Okay, so here I can divide these two equations. Okay, so we can divide them, and from here the value of t will come out to be 16 minutes. You just have to solve it, and after solving the value will be coming out to be 16 minutes. Or you can do in the same way like we did earlier, like from here find the value of k and in this equation put the value of k, or else you can divide the two equations and we will find the answer. Okay. So it's option number 1. Now question number 59. Now this question says, for the first order reaction, the degree of dissociation is equal to 1 minus e upon e raised to power minus kt. A plot of reciprocal concentration of reactant versus time gives a straight line. Okay. Time taken for completion of 75% of reaction is thrice the t half of the reaction. Pre-exponential factor in Arrhenius equation has the dimension of time, means t minus 1. Okay, means time inverse. Now let us see the equations one by one. The statements. Let's see the statements one by one. So students, if I talk about the rate constant for first order reaction, so here I can write it is log of 1 upon 1 minus alpha in terms of the degree of dissociation, which is alpha. Okay, so kt is equal to log to the base e, alright, 1 upon 1 minus alpha. So we can write it as kt is equal to minus log of 1 minus alpha, because I have put it in the numerator. Now to remove the log, what will be the thing here? I will be putting it as e. So it will be e raised to the power minus kt is equal to 1 minus alpha, and from here the value of alpha will be 1 minus e raised to the power minus kt. So it means this is the correct statement, the first one. Plot of reciprocal concentration of reactant versus time gives a straight line. So it is wrong, because plot of not reciprocal but plot of the log of a versus t is a straight line. Okay, so this is wrong. And if I talk about first order reaction, so time taken for 75% completion is twice the half-life of the reaction. You can calculate that. Okay. And yes, pre-exponential factor, that is a. Okay, ea upon rt. So this is the pre-exponential factor. It is also called as the frequency factor. So if it is called as the frequency factor, its unit will be same as that of the rate constant k, and it is time inverse. Okay, time inverse is the thing. So a and d are correct, and answer is going to be option number 3. Okay, and D statements are correct. Now question number 60, the graph plotted between log k versus 1 by t for calculating activation energy is shown by, so students, again you have to write the equation, the Arrhenius equation, which says log k is equal to log a minus e upon 2.303 rt. So if I plot the graph between log k and 1 upon t, okay, so it is like this with a negative slope, straight line with a negative slope, which is minus ea upon 2.303 r, and your intercept will be log a. So yes, the answer is option number 2. That is the correct graph. Okay, question number 61. consider endothermic reaction x to y. Okay, x is changing to y. It's an endothermic reaction, which means it will be absorbing heat. Okay, it will absorb heat. So that is the meaning of endothermic reaction. The activation energies EB and EF are for backward and forward reactions. So which one will be more, that we have to tell. Okay, if the backward reaction energy will be more or forward reaction energy will be more. So students, if I talk about endothermic reaction where heat is absorbed, okay, so you know whenever heat is absorbed, so the delta H, that is enthalpy change for the reaction, will be positive according to this graph. So you know that the the delta H value will be equal to the forward energy reaction energy minus backward reaction energy. So obviously here the E forward will be greater than E backward. Okay, so here you can see this is the forward energy, this is for the backward reaction. So E forward will always be greater than the E backward for an endothermic reaction. So it means the answer is option number 1. Okay, question number 62. The factors affecting the rate of reaction are, so first is temperature, students. Yes, if we increase the temperature, it generally increases the rate of reaction, because higher temperature means more kinetic energy and the number of collisions with sufficient energy will be increased. Okay. Increasing the pressure, again it increases the rate of the reaction because it will increase the concentration of gaseous reactants. Okay. Concentration of reactant and or product. So yes, high concentration of reactants lead to higher reaction rate, of course, because there will be more molecules to collide. So yes, the concentration of reactants will affect the rate of reaction, and yes, catalyst also affect increasing the rate of the reaction because they provide an alternate pathway for reaction to occur by lowering the activation energy. So it means the answer is option number 4, that is all of these are the factors that affect the rate of reaction. Okay. All right. Question number 63. For the elementary reaction, the rate of disappearance of M increases by a factor of 8 after doubling the concentration of M. The order of reaction with respect to M is. Okay, students. So now here the reaction is like this. So if I talk about the rate law, so rate can be written as K and the concentration of reactant. Okay. So here I can write it as X. Let it be X. Okay. Now they are saying that when we are doubling the concentration of M, okay, the rate of disappearance of M increases by a factor of 8. Means the rate becomes 8 times whenever the concentration of M is doubled. Like this. Okay. Now you can just divide these two values. Just divide it, and from here the value of X will be coming out to be 3. Okay, so I can solve that for you. So it will be like, if you divide it, it will be 1 upon 8. K and K will cancel out. So here you have M to the power X, and here you have 2M raised to the power X. Okay, so from here M इसको हम ऐसे लिख सकते हैं 1 upon 8 is equal to M to the power X, here 2 power X, M power X. So M power X will cancel. 2 power X is 8. So you know that 8 can be written as 2 cube. So from here the value of X is 3. Okay. Means this will be the order of the reaction. Okay, it's 3. Now question number 64. So here a reaction is given to you, students. KClO3, potassium chlorate plus ferrous sulfate plus H2SO4. Okay. Which of the following statement regarding the equation is incorrect? So here they are saying we have to find out the incorrect statement. Okay. So it's a complex reaction. Of course, here you can see it is going to be a complex reaction. So students, complex reaction means the one that takes place in multiple steps. Okay. So in that case, this reaction is a complex reaction because it will take place in multiple steps. Okay. Then we have the next one, that is it's a 10th order reaction. So although it is appearing to be 10th order reaction, but it is not a 10th order reaction. It is a second order reaction. Okay. So it means the statement 2 is wrong. It is completed in several steps, correct. It's a second order reaction, correct. So it means this reaction is taking place in multiple steps. So it is a complex reaction. So the incorrect statement is option 2. Okay, that will be the answer. So students, next question is, for the given reaction, half-life does not depend on the concentration of the reactant. After 10 minutes, volume of nitrogen gas is 20 liters, and after the completion of reaction, it is 100 liters. Hence, the rate constant is. Okay, so in this particular question, we need to find out what is the order of this reaction first, then we can apply the integrated rate law. So from the particular question, it is given half-life does not depend on concentration of the reactant. So students, you know that the half-life for the first order reaction is 0.693 upon K. It does not depend on the concentration of reactant. So from here I get to know that the reaction is a first order reaction. So if it's a first order reaction, I'll be applying the equation, that is K is equal to 2.303 upon T log of A upon A minus X. So let's say if the initial concentration is 100, like, and after 10 minutes it is 20 liters, all right. So from here you can say that K will be equal to 2.303 upon 10. So in 10 minutes it's changing from 100 to 20. So 100 divided by 20. So it will be coming out to be log 5. So it's 2.303 upon 10 log 5 per minute. Okay. So yes, the answer is going to be option number 1. Next is factors affecting the rate of reaction are. So students, you know that enthalpy change of the reaction will not affect the rate of the reaction, but yes, the physical state of the reactants, amount of reactant taken, and their surface area, means size of the vessel, it will actually affect the rate of the reaction. Okay, concentration, surface area, and physical state. All right, like in the cases of gases, so like let's say in a smaller vessel, gas molecules are more confined, so there will be more pressure and higher rate of reaction. So you can say कि vessel जो है, it will indirectly affect the rate of gas phase reactions by influencing the pressure. So 2, 3, 4 will be correct, and answer is going to be option number 2. Okay, let's move on to question number 67. So we are given 3 questions. We have to tell that what kind of a reaction it is. Is it a unimolecular, bimolecular, or trimolecular reaction? So unimolecular reaction means a reaction where a single reactant molecule undergoes a transformation to form product. So from here in this case you can see that unimolecular reaction will be here NH4NO, 2 ammonium nitrate is the only reaction. So for A it's 3. Okay, bimolecular, again there will be 2 reactant molecules. Okay, 2 reactant molecules. So here I am having 2 HI molecules. Okay, so 2 HI molecules are there. So it's a bimolecular reactant, and in trimolecular reaction there will be collision of 3 reactant molecules. Okay, so that is 2NO plus O2 that is given. So A3B1C2 is the answer, which is option number 3. Okay, next is question, reaction is given 4A plus 3B gives 6C and 9D. So rate of formation of C is given and rate of disappearance of A is given. The rate of reaction and amount of B consumed in 10 seconds will be. Okay, students, so here you know that in this particular question, so you know rate of reaction is the rate of disappearance of reactant and rate of appearance of product. Okay, so in this particular question, firstly the rate of appearance of C is given. So Now rate of reaction, students, will be 1 by 6 into delta C upon delta T, because 1 by 6 is the coefficient here. Okay, so I will be just writing the value 6 into 10 to the power minus 2 upon 6. So it will be coming out to be 10 to the power minus 2 mole per liter per second. So this is the rate constant. Now the rate of disappearance of B, here we have to tell. So this is the rate of reaction and amount of B consumed in 10 seconds. Okay, so I can write that this will be, rate of reaction will be minus 1 by 3 delta B upon delta T. Okay, so that will be equal to, now if I have to find out, so this is the rate of the reaction, no? So if I have to find out delta B upon delta T, so it will be rate into 3, rate multiplied by 3. So when we will multiply it, so it will 3 into 10 to the power minus 2. And after 10 seconds, I will just multiply it with 10 more. So it will come out to be 30 into 10 to the power minus 2 per mole per liter per second. So answer is option 2. Okay. Next, students, question number 69. There are assertion and reason given to you. So assertion says a reaction can have zero activation energy. So again, a reaction cannot have zero activation energy, because it's the minimum energy required for a reaction to proceed, right? So actually it is the amount of extra energy that reactant molecules must absorb to reach the threshold value. Okay, for the reaction to occur, activation energy is required. So it is not zero, it cannot be zero. Reason is given, minimum extra amount of energy absorbed by reactant molecules so that their energy becomes equal to the threshold value is called activation energy. So yes, this is true. Okay, this is the correct definition that is given for your activation energy. So it means assertion is false but reason is true. Okay, so the answer is going to be option number 3. Now next is the given graph is a representation of kinetics of the reaction. Okay, so the graph is given here in this particular case. So the y and x axis for 0 and first order reaction are, so we need to tell the y and x axis for 0 and first order reaction. So in this case, you know that in zero order, the rate is independent of the concentration, and in the case of first order reaction, the rate will be directly proportional to the concentration. So here you can see the graph, students. For your zero order reaction, the graph will be like this. Rate will be on the y-axis and here concentration. So as I told you, rate does not depend on the concentration, so you will get a flat straight line graph. Okay, so for zero order reaction, y is the rate and x is the concentration. Okay, and again for first order reaction, if I plot the graph, so concentration and rate are directly proportional to each other. So in this case, y will be t half and x will be the concentration. So the answer is option 3. Okay. Next, question number 71. Which of the following curves represents the first order reaction? So students, you know that for the first order reaction, T half is 0.693 upon K. So it does not depend on the concentration. So third graph is actually correct. And for your this thing, first order reaction, the log of concentration of, like you can say A, log A, and T ka effect draw the graph. So it is like this. Okay, straight line graph. So in this case, first and 3 both represents the graph for your first order reaction. Okay. Question number 72. Again, I have to match the reactions. Thermal decomposition of HI on gold surface. So see, whenever decomposition of HI on gold surface happens, it's a zero order reaction because the concentration of reactants on the metal surface remain constant. Okay, so for A you can say it's P. Now if I talk about hydrogenation of ethene, okay, hydrogenation of ethene may, it is a first order reaction because the rate will depend on the concentration of your ethene. And inversion of cane sugar, okay, so for C I can write it's a first order reaction which is R, and for B. Now inversion, if I talk about inversion of cane sugar, it's a pseudo first order reaction because there the concentration of H2O will be taken as constant, okay, in the inversion of cane sugar. So it's a pseudo first order reaction. Okay, for B it's Q, and for D again we are just left with S. Okay, that is the decomposition of gaseous ammonia on a hot platinum surface. It's a second order reaction. So AP, BQ, CR and DS. The answer is option number 4. Okay. So next question, students, a reactant A form two products, okay, and A to B. So activation energy is given EA1 and EA2. Okay, and it is also given that EA2 is twice of EA1. So we have to find the relation between K1 and K2, both of the rate constant. So you know, according to the Arrhenius equation, K is equal to AE raised to the power minus EA upon RT. So we can write the equations for both of them. Now students, we need to divide these two values. Okay, so let's say K1 upon K2 will be equal to A1 upon A2. Here it will be, I'll show you how it is done. E A1 upon RT upon E minus EA2 upon RT. Okay, so you will take it in the numerator. It will become EA1 upon A2. Okay, so E raised to the power, it will become minus EA1 plus EA2 upon RT. Now instead of EA2, write 2EA1. So let me write it here. A1 upon A2, e to the power minus EA1 plus 2EA1 upon R. It will become A1 upon A2 e raised to the power EA1 upon RT. Okay. So A1 upon A2 को लिख देंगे as A, and so K1 will be equal to K2 into A EA1 upon RT. Okay, so it has to be positive. Okay, yeah, it will be positive in this case. Okay, so all the positive values are there. Now moving on to question number 74. Consider the figure and mark the correct option. Okay, so there is a diagram given here and we need to write the correct option. So the first option says activation energy of the forward reaction is E1 plus E2 and product is less stable than the reactant. Of course, so here you can see this is the activated complex. So the total activation energy will be E1 plus E2. And since the product has more energy than the reactant, it is less stable than the reactant. So this is true. Okay. Second statement is wrong. Product is more stable. That is wrong. Activation energy for both forward and backward reaction is E1 plus E2. No, for forward reaction it is E1 plus E2. For backward reaction it is just E1. It is not E1 plus E2. Okay, so it is just E1 and product is more stable than the reactant. That is again not true. So it means these statements are not true. Only true statement is first one. Okay, so answer is option A. Alright, now next is question number 75. Okay, yeah, for its one. Question number 75, which one is an example of pseudo-unimolecular reaction? So you know that whenever one reactant is present in large quantity in excess, so the second order reaction becomes the first order reaction and it becomes a pseudo-unimolecular reaction. Okay, like here we have methyl acetate, okay, plus water. So I think first in the presence of acid, so it will be giving you these two products, so it will become the pseudo first order reaction. Okay, because here the concentration of water will be in excess, so we will be taking it to be constant. See, both the reactions appear to be same, but this is happening in the presence of a base and here acid, so the acidic one. Okay, so this acidic hydrolysis of the ester, it is a pseudo unimolecular reaction. Next, question number 76. So there is a reaction given for nitrogen and hydrogen to give ammonia. Now we need to the equilibrium constant is given, okay, Kc, which is, you know, concentration of product divided by the concentration of reactant. Okay, so I need to match the values of Kc in this case. Okay, so for the first reaction, it's 2N2 plus 6H2 gives 4NH3. So clearly I can see from the normal reaction was this. So the reaction has been multiplied with 2. So if the reaction has been multiplied with 2, the equilibrium constant will also be multiplied with 2. So it becomes 2 Kc. Okay. So for A, it's, in this case, it will be, see, not 2 Kc, but what will happen? Let's say if I am putting the values only here. Let me show you by putting the values. So the powers will get multiplied, no? So in this case, just a minute. So it will be now becoming NH3 raised to the power 4 and N2 raised to the power 2 and H2 raised to the power 6. So it is multiplied by 2, so it means it will become Kc square. Okay, so for A it's S. Now in the second reaction, 2NH3, the reaction has been reversed. Okay, so if the reaction is reversed, the equilibrium constant will become 1 by Kc for the second reaction. Okay, and for the third reaction, it has been divided by 2. Okay, so if it is divided by 2, the power will become half. It will become Kc raised to the power half. So answer is option number 4. A, S, B, R, C, Q. Okay. So 77 question number, students. The value of equilibrium constant increases when concentration of reactants are increased. On increasing concentration of reactants, equilibrium shifts in positive direction. Okay. So students, you know that the value of equilibrium constant increases when concentration is increased. This is false because the equilibrium constant is dependent on temperature and not on the concentration of reactants and products. Okay, so it will remain constant at a given temperature regardless of the change in concentration. Okay, so it means assertion is false. Okay. Next is, on increasing concentration, the equilibrium shifts in forward direction. Yes, so if we are increasing the concentration of the reactant, so according to the Le Chatelier's principle, the concentration of reactant is increased. So system will adjust or it will move in that direction to counteract this change. Means it would want to like reduce the concentration of reactant, means it will be favoring the formation of product. Okay. So equilibrium will shift in the forward direction, but it is not going to change the value of equilibrium constant. That will depend on temperature only. So assertion is false, but reason is true. Question number 78. In which of the following equilibria Kp and Kc are not equal? So you know, students, that Kp is equal to Kc into T raised to the power delta n, and if delta n is equal to 0, it means Kp is equal to Kc. Now delta n means number of moles of product minus number of gaseous moles of reactants. Okay, so in option 1, 2 and 4, if you see, the number of moles on product side is 2, 2 in this case, here also 2 and 2, and here it is 1 and 2, but in fourth it's again 2, 2. So for 1, 2 and 4, the delta n value will be 0. It means Kc will be equal to Kp. But in third option, the delta n value is not 0. Okay, because it is 1. So here the Kp and Kc will not be equal. So the answer is option 3. Okay. 79th question. 2 moles of PCl5 were heated in a closed vessel of 2-liter capacity. At equilibrium, 40% of PCl5 is dissociated into PCl3 and chlorine. So you need to find out the value of equilibrium constant. See, earlier we were having 2 moles of PCl5 and 0 moles of the product. Okay, this I am telling you about the initial. Alright, now, and what happened at equilibrium? 40% of PCl5 is dissociated. If 40% is dissociated, means how much is left? 60% is left, and the concentration of product will again be 40%. Okay, so means 40% is dissociated, so you will get, and the volume of the container is 2 liter. Okay, so these are the number of moles. If I divides with the volume, I will get the molarity, means the concentration. So Kc will be the concentration of product, means 2 into 40 upon 100, and I will divide it by volume, which is 2. Again 2 into 40 and divided by the concentration of reactant. So it will come out to be 0.266. The answer is option 1. That is the equilibrium constant. Okay. Now there is again a reaction given for question number 80. 2A gives B plus C. So Kc value is given. Alright. At a given time, composition of the reaction mixture is A equal to B equal to C, which is 2 into 10 to the power minus 3 molar. So which of the following is correct? Reaction has a tendency to go in backward direction. Reaction has to go completion in forward direction. Reaction is at equilibrium, and reaction has a tendency to go in forward direction. Okay, so here students, the reaction quotient for the particular reaction, it will be given by concentration of B into C upon A square. Okay, for the given reaction we have written the reaction quotient. Now the concentrations are given. So just find out the values. 2 into 10 to the power minus 3 into 2 into 10 to the power minus 3 upon 2 into 10 to the power minus 3 square. So this all will cancel and you will get 1. So QC is 1, and for KC it is 4 into 10 to the power minus 3. So you can see here that the reaction quotient is greater than the equilibrium constant. So it means the reaction will proceed in the backward direction. Answer is option 1. Okay. Next. Question number 81. Acidity of BF3 can be explained on the basis of which of the following concept? So students, you know that in BF3 the boron has only 6 electrons around it. Okay. So it means it is an electron deficient compound. So according to Lewis acid base concept, the species which accepts an electron pair are known as acids. Okay, so this BF3 is actually having 6 electrons around the central atom. So it can accept electron pair. So it will be behaving as a Lewis acid. Okay, so it means the answer is option number 3. Okay, next. Common ion effect is defined as a shift in equilibrium on adding a substance that provide more of an ionic species already present in a dissociation equilibrium. And common ion effect is based on the Leach-Ateliers principle. So students, what is a common ion effect first of all? So it actually says that if we are having certain amount of ionic species already present in the equilibrium, if we are adding a substance that will provide the common ion, okay, means that will provide more of that particular ion. So there will be an shift in the equilibrium, and that shift will be in accordance to the Leach-Ateliers principle. So it means both assertion and reason are true, and reason is the correct explanation of assertion. Question 83, which of the following statement is correct? So acidic buffer consists of a strong acid with its salt and its salt with weak base in a fixed proportion. This is actually Wrong, because acidic buffer consists of a weak acid and its salt with strong base. Okay. pH of a buffer solution changes with dilution. This is also wrong, because pH of a buffer solution is not affected by dilution. Okay, because the log ratio will remain same. Okay. Next is fourth, glycine plus glycine hydrochloride is an example of acidic buffer. No, it's an example of a basic buffer. Third statement is correct, students, because natural buffers are the solution of weak acid and weak base. This is correct. Okay. Question number 84. So the solubility product of AgCl is given, okay, which is 1.8 into 10 to the power minus 10. The concentration of chloride ions that must just be exceeded before AgCl will precipitate to form a solution containing this much ions. So for precipitation, students, the ionic product, okay, the ionic product must be greater than the solubility product. Okay. So it means the concentration of sodium and chloride ions इनका जो product है, it must be greater than the solubility product. Okay. And the concentration of sodium ions is already given. So from here I can find out the concentration of chloride. So 1.8 into 10 to the power minus 10 divided by 4 into 10 to the power minus 3. So it will come out to be 4.5 into 10 to the power minus 8, means the concentration of chloride ion must be more than 4.5 into 10 to the power minus 8 molar. Okay, which is option 1. Question number 85. We have to consider the following statements regarding the equilibrium constant. Okay. So students, the first statement is expression for equilibrium constant is not applicable when concentration of reactants and products have attained a constant value. It is wrong, because the expression of equilibrium constant is applicable then as well. Okay, so this is wrong. Next is the value of equilibrium constant is dependent on initial concentration of reactant and product. So the value of equilibrium constant, students, is independent of initial concentration of reactant and product. This is also wrong. Next is equilibrium constant is temperature dependent, having one unique value for a particular reaction. This is actually true, because the equilibrium constant depends on the temperature, okay, not on the concentrations. Next is fourth statement. So the equilibrium constant for the reverse reaction is directly proportional to the equilibrium constant for the forward reaction. So actually it will be reverse, no? So equilibrium constant for the reverse reaction is equal to the inverse. Okay, like if it is Kc for the forward reaction, so it will be 1 by Kc for the backward reaction. So they are not at all directly proportional. So this is also wrong, means only third statement is true. Okay. Moving on to question number 86. Conjugate base for Bronsted acid H2O and HFR. Okay, so you know that a conjugate base, according to Bronsted-Lowry theory, it is a species that remains after a proton is donated by the acid. So if H2O donates a proton, we will be left with OH minus, and if HF donates a proton, we will be left with F minus. Okay. So yeah, the answer is option third. Okay. Next is question number 87. Equilibrium for the reaction is given, is established in a reaction vessel of 2.5 liter capacity. So the amount of N2 and O2 at the start were 2 moles and 4 moles. Half a mole of nitrogen has been used at equilibrium. So we have to find out the molar concentration of nitric oxide. Okay, students, so in this particular case, let's say if the reaction is like this. Okay, so initially there were 2 moles of nitrogen and 4 moles of oxygen, and at equilibrium half a mole nitrogen is used, means 2 minus half will be left, and similarly 4 minus half will be left for the oxygen. And here 2 into 1 by 2 of nitric oxide, so it's 2 now, because half will be formed, so 2 into half will be formed, which is 1 mole. Now 1 mole, but we have to find out the molar concentration. Volume is 2.5 liters, so it's 1 upon 2.5, so the concentration will be 0.4. The answer is option 2. Okay. Next is the pKa of dimethylamine and for acetic acid are given. The correct option for the pH of this dimethyl ammonium acetate. Now students, dimethyl ammonium acetate, it's a salt of weak acid and weak base. So the pH for weak acid and weak base will be calculated as 7 plus half into pKa minus pKb. Okay, so put the value 7 plus half into 4.77 minus 3.27. Very easy, just put the value, solve it. It will come out to be 7.75. The answer is option 2. Okay, because dimethylamine acetic acid both are weak acid and weak base, so we will be applying this formula. Okay, it's option number 2. Next is the pH of a buffer solution will be equal to the pKa of a acid only. Now see, pH is given by pKa plus log of concentration of conjugate base upon concentration of acid. So if the molar concentration of acid is equal to the molar concentration of base, so it will be log 1 and log 1 is 0. So in that case pH will be equal to pKa. So it means the answer is option 3, that when the molar concentration of acid is equal to the molar concentration of conjugate base. Question number 90. The pH of 0.1 normal acetic acid having Ka value, it is, so if I talk about the acetic acid, it is a weak acid, it will ionize like this. Okay, so initially if the concentration is C 0 0 and at equilibrium C into 1 minus alpha, and here C alpha and C alpha. Okay, so the concentration of H positive is C alpha here. Okay, or you can write it as under root of K alpha Kc upon C. Okay, so Ka, or you can write Ka upon C. So just put the values here. Okay, because you know alpha is equal to under root of Ka upon C. So C into Ka upon K alpha. So from here you can put the values. So it will be coming out to be under root of Ka into C. Okay. So Ka into C is the concentration that is given. So put the values here, and from here pH will be equal to minus log of H plus. Okay. Alright. So from here find out the concentration. So from here we have calculated the concentration of hydrogen ions. Ka is already given 1.8 into 10 to the power minus 5 into concentration is given 0.1. So it will come out to be 1.34 into 10 to the power minus 3 molar. So now just take the log of it. 1.34 into 10 to the power minus 3. So you will solve it and it will come out to be 2.9. Okay. So it's option number 1. Question number 91. Which one of the following will make a basic buffer? Okay, so in this question students, so we have to find out the concentrations. Okay, first case mein we have 100 ml of 0.1 molar acetic acid and 0.1 molar 100 ml of 0.1 molar NaOH. So it's not a basic buffer because here this salt we will be getting na sodium acetate, and hydrolysis of salt takes place, and final solution it will be having salt of weak acid with strong base only. Okay, and in the second case we have 100 ml of 0.1 molar HCl and 200 ml of 0.1 molar ammonium hydroxide. So yeah, in this case we will be getting a basic buffer because final solution will be having a weak base and its salt with strong acid. So it's option number 2. Okay, third wale mein we will be getting a neutral solution. Okay, because with a strong acid and a strong base. And in the fourth one we will be getting a basic solution. Okay, basic, here it will be neutral. Okay, so next is question number 92. Calculate the solubility of A2X3 in pure water, assuming that neither kind of ion reacts with water. Okay, the solubility product is given 1.1 into 10 to the power minus 23. So, you know that A2X3, if we are having, it will be ionized like this: A2 positive, sorry, 3 positive and 3X2 minus. Okay, so the solubility product will be A3 positive square into X2 minus cube, which is already given 1.1 into 10 to the power minus 23. Okay, so if I take S as the solubility of A2X3, so A की concentration यहाँ पर क्या हम ले लेंगे, it will be 2S, and for X we will be taking it as 3S. Okay, we are taking the solubility. So यहाँ पर put कर दो 2S square into 3S cube. The value is 1.1 into 10 to the power minus 23. So यहाँ से just solve this. Okay, 4S square into 9. 3, okay, 3 cube na 27. So S cube. So it will be 4 7s are 28. Okay, 108. 108 S to the power 5, it's 1.1 into 10 to the power minus 23. So from here you can find out the value of S. Okay, so it will come out to be 1.0 into 10 to the power minus 5. Next is question number 93. Consider the following reaction in a sealed vessel with a concentration given. So, and it is given that if 0.1 mole per liter of nitric oxide is taken in a closed vessel, what will be the degree of dissociation of nitric oxide at equilibrium? Okay, so firstly we will be finding out the value of Kc, concentration of product upon reactant. Okay, because we are talking about the dissociation of nitric oxide, so it will be dissociating like this, N2 and O2. So by putting the concentrations, N2 की concentration, O2 की and NO की, it's given. Okay, so just put the values and you will find the Kc. It will be 1.6. Okay, now let's say if T equal to 0 पे the concentration of nitric oxide is 0.1. Okay, it's given 0.1 mole per liter. So initially it's 0 and time T पे if it is x and x is formed, so 0.1 minus 2x. तो यहाँ से Kc की वैल्यू क्या हो जाएगी at equilibrium? X square upon 0.1 minus 2x. But you know Kc will remain same, 1.6. So just find the values from here. Okay. Also it will be square because we have 2 NO. Now you can take the square root both sides. Okay, and after taking the square root both sides, find the value of x. It will come out to be 0.07. Now that you have got the value of x, so you know that x is equal to C alpha, okay, which is 0.07, because see, this is how we take na C alpha, and C alpha which is the concentration. So from here 0.1 into alpha is 0.07. So यहाँ से अल्फा की वैल्यू आ जाएगी 0.07 upon 0.1. So it's 0.717 it will come. So answer is option number 2. Okay. Next is question number 94. Which of the following is not a general characteristic of equilibria involving physical processes? So equilibrium is only possible in a closed system at a given temperature. So students, you know it's true. So at what happens is, at the stage of equilibria, physical processes like melting of ice, freezing of ice, they don't stop, but the opposite processes, means forward and reverse process, happens at the same rate. So it means third statement in which it's saying all the physical processes stop at equilibrium, it's wrong. All measurable properties remain constant. This is true. It is happening in a closed vessel. This is true. Opposing processes occur at same rate. This is true. The opposite processes forward and backward happens at the same rate. Okay. So that is also true, means the answer is option 3. Question number 95. Ionization of hydrogen sulfide in water is low in the presence of HCl. Reason: hydrogen sulfide is a weak acid. So you know students that H2S is a weak acid and also a weak electrolyte, and its ionization is suppressed when some HCl is added. Okay, because it's a weak electrolyte, if we are adding it HCl, so its ionization will become less. Okay, because of common ion effect. So common ion is the reason that the ionization is low in the presence of HCl. So it means assertion and reason both are true, but this reason that H2S is a weak acid is not explaining the ionization. Okay, so it means reason is not the correct explanation of assertion. So answer is option 2. All right. Next, question number 96. Molar solubility of calcium fluoride in 0.1 molar solution of NaF will be. So from here you can write Ksp is equal to calcium ions concentration into fluoride ions concentration, Ka square. Okay, so from here we have to find out the molar solubility in 0.1 molar solution of NaF. So it means the Ksp is given. Let's take the concentration of calcium ion to be X, and for NaF it's given it's 0.1 molar solution of NaF, means the chloride ions will be 0.1 square. Okay, so यहाँ से you can find out the value of X. It will come out to be 5.3 into 10 to the power minus 9 molar. Okay, the answer is option 3. Next question, assertion: buffer solution of carbonic acid and sodium bicarbonate is used for precipitation of third group elements. It maintains the pH to a constant value of 7.4. So you know students, in biological systems, buffer solution of carbonic acid and sodium bicarbonate is found in our blood. It maintains the pH of the blood. So we are talking about the pH of the blood, which is around 7.4. So it's not used for the hydrolysis of third group element. So its assertion is incorrect, but reason is correct. Okay, so it's option number 4. Next question. Here we have to match the list with their pK values that you have to remember. For benzene amine it's 9.38, phenyl methane amine it's 4.70, methane amine it's 3.38, and ethyl ethane amine and ethyl ethane amine it's 3.0. So answer is option 1. Okay. Next is HCl was passed through a solution of calcium chloride, magnesium chloride and NaCl. Which of the following compound crystallizes? So you know students that when we are passing HCl through the solution of calcium chloride, magnesium chloride and NaCl, concentration of chloride ion increases, and calcium chloride and magnesium chloride are more stable than sodium chloride. So the ionic product of sodium chloride, it is more than the solubility product. Okay, so precipitation of NaCl will happen due to the common ion effect. Okay, it will precipitate because here the ionic product will be more than that. All right, last question. the value of Kc for the reaction is given at the time the composition is given, the which direction reaction will proceed. Same kind of question we have just done. So find the value of reaction quotient for this reaction, B into concentration of C upon A square. Concentration is given 3 into 10 to the power minus 4. Same, just a same question we have done. So it's 1. Okay, again here the value of Qc is greater than the equilibrium constant. So it means the reaction will proceed in the backward or the reverse direction. Okay, means it will favor the formation of the reactants. So students, that was your chemistry portion for this BPT 10. I hope all the questions are clear. If there are any doubts, you can ask us in the comment section. Okay. So try to solve all these questions and all the best for your next exam. Thank you so much. Bye-bye.